objective of this panel discussion is how we can effectively utilize the steel slag aggregate not only in road construction besides the other civil engineering construction activity.
So while it's taking time for the IRC guidelines or the guidelines from MORTS to come, immediately like the steel industries, those who are interested in creating a brand of aggregate can reach IRC, try the accreditation of material route. The guidelines will be further helping. That is for sure. So that could be the first step.
So far as EAF slags are concerned, we have already showcased in Hazira and it's a wonderful job which has been done. So for the country to go green, to reduce the carbon footprint, we have to mandate that minimum this much percentage you will have to use slag only. You have no option. And slags are available there. It can be a little more expensive, but it has to be done.
The steel slag, and it was well known in Japan even at that time that steel slag has a better quality, it has longevity, it has sustainability, and it has better properties when used in the cement than compared to that natural aggregate. The thickness of the pavement, which is the minimum thickness required for the natural aggregate, can we reduce that thickness when we use the minimum thickness when we use the steel slag? So that is the first area we are looking at, the optimizing the thickness. Steel slag fly ash mixture in our roads with the same kind of properties we can get. So this is the second area we are looking at.
Almost 10 years now since the first experiments were happening somewhere in the beautiful locales of Jamshedpur called Dimna, where they were trying to see what we can do with steel slag. Whether we like or we don't like, there'll soon come a time when natural aggregates won't be available. And therefore it is most important that for India to grow sustainably, there are two major, I would say, areas which will grow, again talked about in the morning. One is making of roads, which will open up the economy. And second, steel has to grow. And when steel will grow, this slag will be available, and we have to create opportunities where this slag can be commercially utilized.
There are technologies like silane which work on the principle of changing of the interfaces from the free silanols which are there is converted into a alkyl siloxane surface. So in net terms, what happens is you create a chemical skin on the aggregate, irrespective of whether it is a slag aggregate or a God-given natural aggregate. As long as there is a silicate, you create a human skin on the aggregate. No water can go in. Can we bring chemistry and physics streams into this? And you yourself are doing your PhD, or you have done it already in silence. I think silence can play a big role in terms of preventing leaching into the soils by not allowing water conductivity into the stabilized mass, irrespective of the thickness, irrespective of the width.
Terex India is, or the Terex Corporation is taking in terms of doing recycling of steel slag. Recycling involves all kind of processing, starting from screening to crushing, primary crushing with the jaw, the secondary crushing from the impact crusher, and then again processing. So we have got a complete line of product line from jaw crushers, impact crushers, HSI horizontal shaft impactors and vertical shaft impactors. We are also launching hydrocyclones for washing of these steel slags further to make it more refined product to get used into the different road layers.
Why we all have addressed here is to address the issue of sustainability, because when we talk about 4 R's, reduce, reuse, recover and recycle. 1993, if you see that time publications, everybody used to say fly ash is toxic in nature. Time changed, lot of research happened, then it was called as hazardous material. Time changed, then we started calling it as secondary resource material. Time change, we started calling it primary resource material. And nowadays, any captive thermal power plant around, if you go, they say we produce 2 things. One is electricity for the consumers, second is fly ash for the cement industry. So similarly, if institutions like Central Road Research Institute or other institutions, they are looking forward some kind of solutions. So believe me, time will come when we will find that there will be no legacy of this kind of slag will be available. It will be used in one way or other.
There's sometimes certain technologies which go so far in creating a sustainable future for all of us that conferences like this and agencies like CRRI are absolutely essential to develop these things so that we can have a very, very lasting impact on our environment. So UPRRDA also partners with CRRI on various technologies. We are now working with them on CGBM technology, on cold mix technologies, MSS+, which are also going forward in creating a sustainable future. My absolute congratulations to everyone in this room who is becoming a part of this technology. As UPRRDA, as a rural roads building organization, we would be taking this and any other technologies. It's an open offer to CRRI. Whenever you come up with a new technology, you please take it for granted that we will be using your technology in one of our roads so that you can have actual practical use cases to showcase. That is my promise to you. And I hope that all of us together can take this country to greater heights and also to heights where all of us can move together instead of just leaving like 90% of the country behind. That's my hope and dream, and I hope you will agree, and I hope that you will also do whatever bit you can for that. Thank you so much.